Every single minute of unplanned downtime in your operational infrastructure bleeds capital, eroding profit margins with brutal, compounding efficiency. For decades, global logistics networks accepted this hemorrhage as an unavoidable cost of doing business, relying on reactive strategies that only addressed equipment failures after the financial damage was already done. You are managing massive fleets, complex industrial machinery, and uncompromising delivery schedules, yet relying on historical averages to predict future breakdowns leaves your entire enterprise vulnerable to catastrophic, cascading delays that destroy client trust. FedEx shattered this legacy paradigm by aggressively pivoting toward a proactive, data-driven architecture powered by advanced artificial intelligence. They recognized that true market dominance required completely eliminating the friction of mechanical unpredictability across their vast global supply chain. By integrating AI for predictive maintenance, they transformed their physical infrastructure from a reactive vulnerability into a sentient, interconnected network capable of anticipating its own mechanical failures before they ever occur. This strategic shift fundamentally alters the competitive landscape by converting a traditional, capital-draining cost center into a formidable mechanism for operational optimization. Instead of waiting for a cargo aircraft engine or a delivery vehicle to fail in the field, algorithms now analyze continuous streams of telemetry to forecast exact failure horizons with mathematical precision. You are no longer reacting to a logistical crisis. You are preemptively neutralizing it before it ever impacts your service level agreements or your bottom line. The foundation of this predictive capability rests on the massive strategic deployment of IoT sensors across every critical node of the physical logistics network. These devices capture highly granular data points ranging from engine vibration and temperature fluctuations to hydraulic pressure anomalies and irregular fuel consumption. This continuous ingestion of real-time telemetry creates a high-fidelity digital twin of the entire physical fleet, feeding raw, unstructured data directly into sophisticated machine learning models designed for enterprise scale. Those models utilize deep neural networks to detect micro-anomalies that human operators and traditional diagnostic tools would completely miss in the noise of daily operations. By cross-referencing current sensor outputs with decades of historical maintenance logs, the AI identifies the subtle, complex patterns that reliably precede a specific component failure. The system calculates probability scores for thousands of individual parts simultaneously, generating highly accurate, actionable timelines for required mechanical interventions. The immediate operational impact of this predictive capability is staggering, drastically reducing the unscheduled maintenance events that historically paralyzed sorting hubs and grounded high-value flights. Mechanics are now dispatched with the exact parts required for a specific repair before the vehicle even returns to the primary depot, optimizing labor allocation and minimizing turnaround time to the absolute limit. This precision dramatically increases the overall utilization rate of multi-million-dollar capital assets, extracting maximum value from every piece of equipment. The echoes of those initial efficiency gains rapidly compound across the entire enterprise architecture, fundamentally changing how capital is deployed. When your maintenance schedule is dictated by algorithmic foresight rather than arbitrary calendar dates or sudden breakdowns, you completely eliminate the massive buffer inventories previously required to hedge against mechanical uncertainty. Capital that was once trapped in dormant spare parts and redundant backup vehicles is aggressively reallocated toward market expansion, technological innovation, and aggressive customer acquisition. However, executing this transformation required dismantling deeply entrenched data silos that historically separated maintenance records from flight operations and routing logistics. Legacy enterprise resource planning systems were fundamentally incapable of processing the sheer velocity and volume of IoT data required for real-time predictive analytics at this massive scale. Leadership had to force a structural integration, demanding cross-functional data fluidity to feed the central AI brain and overcome fierce internal resistance to new operational protocols. Overcoming these internal barriers necessitated the construction of a unified cloud-based data lake capable of standardizing disparate telemetry streams from thousands of moving assets. This centralized repository acts as the single source of truth, allowing machine learning models to train on a comprehensive, unified dataset that reflects the true, holistic state of the global organization. You must build this foundational data infrastructure before you can extract any strategic value from predictive algorithms or attempt to scale AI across your operations. Once that unified architecture is established, the predictive insights elevate the organization from a reliable logistics vendor to an untouchable market leader with absolute pricing power. Competitors still operating on reactive maintenance schedules simply cannot match the cost models or the ironclad delivery guarantees of a completely optimized, AI-driven fleet. The ability to mathematically guarantee uptime translates directly into premium enterprise contracts, unshakable customer loyalty, and a dominant market share that legacy competitors cannot contest. Quantifying this dominance reveals massive reductions in operational costs that drop directly to the bottom line, fundamentally altering the unit economics of the business. By replacing parts precisely at the end of their actual useful life, rather than prematurely based on a conservative manual, material expenses plummet across the board. Furthermore, preventing catastrophic mid-route failures eliminates the exorbitant costs associated with emergency towing, expedited replacement vehicles, and the devastating financial penalties of missed delivery windows. The true genius of the strategy lies in expanding these predictive maintenance insights directly into broader supply chain optimization engines. The AI does not merely schedule a repair, it communicates the impending downtime to the global routing algorithms in real time. This interconnected intelligence allows the network to dynamically reroute packages and reassign vehicles long before a predicted mechanical issue causes a localized bottleneck or delays a critical enterprise shipment. If an algorithm predicts a high probability of a critical component failure on a specific cargo plane within the next 48 hours, the system automatically intervenes without human hesitation. It schedules the maintenance during a naturally occurring dwell time and simultaneously shifts that plane's high-priority freight to an alternate route using available network capacity. The end customer experiences zero disruption, completely unaware that a major logistical crisis was just algorithmically averted behind the scenes. This level of seamless preemptive orchestration creates a fiercely resilient supply chain that is virtually immune to the mechanical friction that routinely paralyzes traditional networks. When global disruptions inevitably occur, the AI-powered infrastructure possesses the inherent agility to absorb the operational shock and instantly recalculate optimal workflows across millions of variables. You are building an operational fortress where machine intelligence continuously patches vulnerabilities before they can be exploited by market volatility or aggressive competitors. Looking ahead, this deep integration of predictive maintenance and dynamic routing represents the critical stepping stone toward fully autonomous logistics networks. As self-driving trucks and automated cargo drones begin to enter the enterprise fleet, their operational viability will depend entirely on these underlying predictive health monitoring systems. An autonomous vehicle cannot rely on a human driver to notice a strange engine vibration. It requires absolute, continuous algorithmic certainty regarding its own mechanical integrity to operate safely at scale. The lessons from that initial data integration continue to shape the trajectory of advanced enterprise scaling across all modern industries. You must view predictive maintenance not as a localized technology project for the mechanics, but as a core strategic pillar that dictates your overall operational capacity and market valuation. When the physical health of your assets is perfectly synchronized with your digital routing engines, you achieve a state of continuous, uninterrupted execution that redefines industry standards. This synchronization aggressively mitigates the profound risks associated with global supply chain volatility, labor shortages, and unpredictable economic headwinds. By mathematically minimizing the operational variables you can control, specifically equipment failure and unscheduled maintenance downtime, you insulate your profit margins against external shocks. The AI acts as a sophisticated financial shock absorber, ensuring that operational costs remain fiercely predictable and tightly controlled, even when broader market conditions become highly chaotic. To replicate this level of control within your own enterprise, you must initiate a relentless, comprehensive audit of your current data capture capabilities across all physical assets. Identify the blind spots where machinery operates without generating continuous telemetry, and rapidly deploy the necessary IoT sensors to illuminate those dark operational corners. You absolutely cannot predict what you cannot measure, and you cannot optimize a supply chain that you do not track in high fidelity real time. The most significant hurdle you will face during this implementation is rarely the procurement of the sensor hardware, but the cultural resistance from veteran operators accustomed to intuitive oversight. Middle management often views algorithmic directives with deep skepticism, preferring the comfort of established, albeit highly inefficient, legacy protocols and manual scheduling. You must decisively mandate the adoption of AI-generated insights, tying leadership performance metrics and compensation directly to the aggressive utilization of predictive data. Establish a dedicated AI integration task force composed of both elite data scientists and seasoned operational commanders to bridge this cultural divide and accelerate deployment. This coalition ensures that the machine learning models are trained not just on raw telemetry, but on the nuanced, practical realities of your specific business environment and physical constraints. The algorithms must deeply understand the operational context to provide predictive recommendations that are actually executable on the warehouse floor or the tarmac. When this cross-functional alignment is achieved, the return on investment accelerates exponentially, moving far beyond simple maintenance savings to impact every department. The procurement team leverages the predictive data to negotiate highly favorable just-in-time contracts with parts suppliers, knowing exactly what components will be needed months in advance. Sales teams utilize the guaranteed uptime metrics as a decisive weapon to close premium enterprise accounts, promising a level of reliability that legacy competitors simply cannot match. This compounding value creates the ultimate strategic moat, built on a massive foundation of proprietary data that no competitor can easily replicate, purchase, or reverse engineer. The longer your machine learning models ingest telemetry from your specific operations, the more accurate, nuanced, and bespoke their predictive capabilities become. You are generating a unique, self-reinforcing intelligence asset that continuously widens the operational gap between your enterprise and the rest of the stagnant market. The competitor's shadow still looms, but their reliance on historical averages renders them permanently a step behind your predictive foresight and operational agility. They are playing a dangerous game of chance with their physical infrastructure, while you are executing a mathematically guaranteed strategy of continuous optimization and risk elimination. In the modern B2B landscape, the margin for error has completely evaporated, and survival dictates that every asset must perform at absolute peak efficiency. The era of reactive management is officially dead, replaced by a hyper-efficient reality where artificial intelligence dictates the precise rhythm of global commerce and logistics. Companies that fail to integrate predictive analytics into their core physical operations will find their margins crushed by the sheer weight of their own inefficiency and downtime. You must embrace this technological imperative immediately, transforming your legacy infrastructure into a proactive, intelligent network that anticipates the future rather than reacting to the past. This is the definitive blueprint for unquestionable market dominance in an increasingly complex, data-driven, and unforgiving economic environment. By mastering AI for predictive maintenance and supply chain optimization, you elevate your enterprise above the chaos of operational friction and mechanical uncertainty. You secure the absolute power to dictate terms to the market, delivering flawless execution at massive scale and leaving your competitors struggling to navigate the disruptions you have already mathematically eliminated.